Hello dear students, let us solve some multiple choice questions from first law of thermodynamics asked in final examination of NEB Nepal. Asked in class 12 final examination of NEB Nepal. Question number 1 is, for an isochoric process, temperature changes from 127 degrees Celsius to 227 degrees Celsius. The ratio of initial to final pressure is. So, solution to question 1. Equation of state for ideal gas is P1 V1 upon T1 is equal to P2 V2 upon T2. For isochoric process, volume is constant, so volume gets cancelled. Therefore, we get P1 upon P2 is equal to T1 upon T2. T1 is 127 means 400 Kelvin and T2 is 227 means 500 Kelvin. So, the ratio of P1 and P2 comes to be 4 by 5. So, the correct option will be A. Next question number 2. Next question number 2. Question is, an ideal gas is taken through a series of changes represented in the diagram. The work done by the gas at the end of cycle is. This is PV diagram for an ideal gas. Work done in this complete cycle will be the area of triangle. So, work done will be equal to area of triangle ACB. This will be 1 upon 2 into AB means 6 Pascal में minus 6 Pascal में minus 2 Pascal into 6 cm cube minus 3 cm cube means 6 minus 3 and cm cube is equal to 10 to minus 6 meter cube. So, work done comes to be 6 into 10 to minus 6 joules. So, the correct option will be A. Next question number 3. In which of the following processes of the gas work done is maximum? So, solution to question 3. We know that the area covered by the isobaric process with volume axis is maximum. Therefore, work done by isobaric process is maximum. So, the correct option will be C. C, because area covered by isobaric curve with volume axis is maximum among other processes. Next question number 4. Internal energy of an ideal gas depends on, these are the options, because change in internal energy is equal to N CV dt. So, it only depends on temperature change. So, the correct option will be A. Next question number 5. An ideal gas is taken through series of changes shown in diagram. Net work done at the end of cycle is. An ideal gas is taken through series of changes shown in diagram. Net work done at the end of cycle is. These are the options. Work done will be area of this triangle, that is 1 by 2, 6 P1 minus P1 into 3 B1 minus B1, which gives 10 P1 B1 upon 2 means 5 P1 B1. So the correct option will be C. Next question number 6. The question is, a gas having gamma as gamma equal to 5 by 3 at 27 degrees Celsius, at 27 degrees Celsius is compressed adiabatically from 27 liters to 8 liters. The rise in temperature is solution to question 6. Here T1 B1 gamma minus 1 will be equal to T2 B2 gamma minus 1 for adiabatic process, which gives T2 as T1 B1 upon B2 gamma minus 1. T1 is 27 degrees Celsius means 300 Kelvin. B1 is 27 liter upon B2 is 8 liters, liter cancels, and gamma minus 1 means 5 by 3 minus 1, which gives 300 into 27 upon 8, 2 by 3, which gives T2 as 675 Kelvin. Therefore change in temperature will be T2 minus T1 is equal to 675 minus 300 means 375 Kelvin or 375 degree Celsius, because we know delta C is equal to delta K. So the correct option will be B. Next question number 7. During adiabatic compression of gas, its temperature. Solution to question 7. For adiabatic process, T1 B1 gamma minus 1 is equal to T2 B2 gamma minus 1. So T2 will be equal to T1 into B1 upon B2 whole gamma minus 1, which shows that T2 will be greater than T1 because B1 is greater than B2. Thus, the temperature rises is correct. Option B is correct. Next, question number 8. Identify the wrong statement. These are the statements. For isothermal process, delta T is 0. This is correct option. For isothermal process, delta T is 0. Correct statement because T is constant. For isochoric process, delta V is 0. Correct statement because V is constant. For isobaric process, delta P is constant. Correct statement because P is constant. D. For cyclic process, delta W is 0. This is wrong statement. Therefore, the correct option will be D. Solution to question 8. For cyclic process, delta U is 0, but in this option delta W is 0. Hence, the statement for cyclic process delta W is 0 is wrong. So, this is the correct option. Next question number 9. Question is, for an ideal gas, the ratio of heat capacities is 5 by 3. At 72 degrees Celsius, the gas is expanded adiabatically to 8 times its original volume. Approximate change in temperature of gas is. Solution to question 9. Here for adiabatic process T1 B1 gamma minus 1 is equal to T2 B2 gamma minus 1, which gives T2 as T1 into B1 upon B2 whole gamma minus 1, T1 into B1 upon B2 whole gamma minus 1. T1 is 273 plus 72 Kelvin, B1 is B1 and B2 is 8 B1, gamma minus 1 means 5 by 3 minus 1, B1 B1 cancels, so T2 comes to be 273 plus 72 into 1 by 8 power 2 by 3, which gives 345 into 1 by 8 power 2 by 3, which is 86.25 Kelvin. Therefore, delta T will be equal to T1 difference T2, that is 345 minus 86.25, which is nearly equal to 259 Kelvin. So the correct option will be C.